Hello everyone, how are you? I'm Ruchira. So today I'm going to explain you about solids, liquids and gases today. So are we all ready to learn? Yes. So before learning solids, liquids and gases, we need to know what is matter. So what is matter? So, matter can be anything. It can be either a book or a pencil. It can be anything, but it should take some space. See, you can see that here I'm having some space. So, it should take some of that space and it should have mass. What is the meaning of mass? It should have some weight. So, for example, this pen you can see, right? Yes. So, now tell me that is it taking some space? Yes. Either on the screen it is taking this space, you can tell, or you can also tell that on the floor it is taking how much space? This much space, right? The shape of the pen, how much it is there, that much space this pen will be taking. So I might call this pen as matter. Getting it? Yes. So this pen is matter. Yes? Yes. So now, see, you can see that this pen was there, right? Yes. To make this pen, there will be little, very small particles. Yes, it is actually made up of little small particles. Not only the pen, even your books. Yes, it is made up of small particles. Yes. So what do we call these particles? We call them molecules. Yes, the little small particles we call as molecules. Get it? Yes. So now we are going to learn the states of matter. So matter, we already learned, right? What is the matter? It occupies some space and it has mass. Yes. So there are three states of matter. Okay. So in there are three states of matter. So what are they? We are gonna learn. So the first one is solid. So what is a solid? Yes. What is a solid? You can observe in this picture that these are molecules. Okay, these are the little molecules. I'll draw again if you want. Yes, I will draw. See, this is one molecule. Molecule number one. Yes. Now see, observe carefully. This is molecule number one. This is molecule number two. This is molecule number three, and so on. Yes, you can see that they are tightly packed. See, after another, there is no gap in between. Yes, so this is the first state of matter. It is solid. So for the example, again you can take as this pen itself. Yes, see this pen. How is this pen made? It is made by little molecules, I know. But the molecules, see, if this is one molecule, here another, and so on. Then here the ending point, one molecule will be there. Again, the cap will have some molecules. Yes, like this only the pen is made. So you can observe that there's no gap between these molecules. So this pen is the matter also, and it is the solid state. It is in the solid state of matter. Get it? So in this states of matter, the first one we discussed is solid. The pen which we have is also the solid. Get it? Yes. So again I will repeat once again, there is very less gap in this space. Yes. Now I'm going to tell. So you might call these molecules of the solids our best friends. Yes, for our understanding. We can, right? Yeah, only for our understanding we can call, right? They are best friends. Yes. So see, the solid, always they are tightly packed. See, you can observe here very clearly. This is one molecule, molecule number 2. See here, these are the molecules. You can see very less gap here. Yes, right? There is very less gap in between. You can see this is one molecule and this is one molecule. Yes, I'm drawing once again to make it clear. Yes, and middle of these molecules there is very less gap. So they are tightly packed. Packed means not packed in a box. Not like that. They are very near to each other. Yes? Yes. And they are always specific. Okay. So, now let's take a book. Okay. And here there is a table. Okay. Yeah, this is the table. And here it is the chair. I don't know. Yes, you should imagine. Huh? Yes. Okay. So this book I am going to take and keep it on this table. So it will become again pen. No. Will it become scale, ruler? No, right? It will be book only. Now I will keep this book on the chair. Now also it will be book only, na? It will become now chair. No, right? No, it will be book only. It has the specific shape. It is very specific in nature. Yes. And there is strong intermolecular forces of attraction. So you can see that there is very less amount of space in between these molecules. Yes? Yes. So they do not move from one place to another. See, if this molecule is here means it will never move to this end. It will always be there here only. It will never move to the other place. It will always be in that particular place only. So the solids never change their places. If these two molecules are there, then they too will be here only. Yes, They will never move and sit here. Yes, yes. So they always vibration, right? They always vibrate. They have the ability to vibrate. So these substances are hard and they're always rigid. Yes, what they are? They are always hard and they're always rigid. Get it? Yes. What is the meaning of hard? If you take a bench, yes, a flat table or something like that, or the board, the whiteboard or the blackboard which you have. Yes, if you take that as an example, you can see that the board is hard. Yes, you have at least once you have pressed the whiteboard, you have felt the whiteboard, or you will know, right? You will know that it is very hard. Not very, at least it, when we touch, it won't get squished. It is having its own energy. Yes, yes. So it is always hard. It will have a hard structure and it is always rigid. Yes, yes. So it will have definite shape. That shape only, as I told you. And also volume. Volume will also be always same. It will never ever change. Yes, yes. So you can see that I have kept some pens here. Yes, you need to imagine that these are molecules. Okay? Yes, will you be able to imagine that these are molecules? Yes, yes. So see, molecule, molecule, molecule. You can see, right? They are very, very near to each other, right? They are very, very near. You can see. After this only this will come. After this only this will come. Yes. Yes. So this we can call, mainly this part you can observe clearly. Yes. Which part? This part. It is very, very clear in this part that there is very less gap. You can observe in every molecule there is very less amount of space in the middle. Here also, see, very less. But this is very clear, I'm telling. Yes, yes. So you can see how much tightly they are packed means even if I'm trying to make them fall, they are not falling. Yes, yes. The molecules are very tightly packed. You can see I have tilted. Yes, but still they will not fall. They will never change their shape because they are in solid state. Yes. Yes, now we're going to move on to the liquid. So you can see these molecules. Observe them very carefully. They are not like solids. Have you observed the solid? Yes, I shown you. You want me to show again? Yes. See, this is the solid. See this. Observe each molecule. Observe each molecule. How they are packed. How much space is provided. Yes, observed. May I go to the liquid? See this also. It is solid. Here also. Observe. Everywhere observe. So now liquid. Can you suddenly feel the difference? Yes, when I show you that and suddenly show this, you will be able to identify, right? This is something different. Yes. So you can see that I can just get some space, not more, not so much, but yeah, say I'm able to draw one full line. And here also more space is there. Here also. Yes, I'm able to draw more. Means I'm able to see so much space here in the liquid. So let's see what is this. So here you can observe in a zoomed manner that, see, this is the molecule number 1. This is the molecule number 2. Yes, this is the molecule number 3. Yes. So here there is some gap between. There is some gap between these molecules, not more. Just a little bit gap is there. It is there. Yes. Yes. So they are loosely packed, right? They're not very tight. They are very loose, but they're not very like they can't go where they want. Yes, they are loosely packed and they can flow where they want. Yes, they can go. Yes, of course. They can go where they want. See, if this molecule want to go here means yes, it can. No restrictions to go. Yes, so they flow freely from higher to lower levels. Yes, from higher to lower levels they flow freely. Here, intermolecular forces of attraction, it is less. Okay, in the solids it is very strong, but in the liquids it is a little less. Compared to the solids, it is less. Yes, and you can see it can move to different containers. This is water. Yes, water. Here I have stored water. You can observe, if you can observe this line. Yes, that is the water. Okay, that is the water I have stored inside this bottle. So now I can put this inside a cup. Can I? No? Yes? Yes? Or what? Yes or no? Yes, of course. I can put this water to a cup. Yes, and that water, what it will do? It will take the shape of that cup. Yes? Yes, of course. So that only I want to tell, that it takes the shape of the container. If I put in a bottle, it takes the shape of the bottle. If I put in a jar, it takes the shape of a jar. If I put in a bowl, that bowl shape. If I put in one vessel, it takes the shape of that vessel. Yes? Yes. So it does not have any definite shape. See, if it is moving, that's in that cup means it will take cup. Bottle. It is not having any shape, but it has volume. It always has volume. Get it? So here you can see how the molecules will be packed. Here also you're gonna imagine that these pens are the molecules. Yes? These you can imagine that these all pens are molecules, and you can observe how they are packed. I'm going to show you. Look, I'm going to show you only with the pen cap so that it is easier. So molecule number 1, molecule number 2, molecule number 3, molecule number 4, molecule number 5, etc., etc., etc. Yes, you can see that there is some gap between. Yes, Here also there's some gap between. Actually, here also gap is there. As I have drawn the circle, right? See, observe only this and this. See, there's gap in between. Right? Yes. So, it is far away, means not very far. The molecules are loosely packed. Get it? Yes, you can observe very clearly. So, see, it is zoomed out how it takes the shape of the container. Zoomed out. Yes, it is zoomed. I poured this much water and that shape only it has taken, the cylinder shape. Yes, now we're gonna move on to the gases. You're very surprised by looking these gases, aren't you? Yes, or not you? Of course, yes. You can see that even if there are very lesser number of molecules, they are taking more space, right? Yes. Okay, wasting of space. Yes. No. Yes, it's okay. Yes. So, see, here is one molecule, here one, like this. They're very far. For example, air. Air, you know, na? Air. We cannot see air. Yes. Now, catch some air in your hand. See that air. No, you can't see it. But you can catch and feel it. Yes, it is true. But air is there, na? You can't catch it just one place. Because the molecules are very far away. Yes, from each other. They are very far. You can call them, they are never gonna be friends. Yes, so solid they are best friends, liquid they are friends, and gases they can never be friends. Like that you can call them. Yes, so deeper we're gonna see it. Here it is very clearly mentioned that here one molecule, here one molecule, here one, here one. It is very clearly zoomed that here so much gap is there, here so much gap is there, here so much gap is there. We can walk around. Yes, if it was made as a path, we could have walked here. Yes, it is so much gap it is there. Yes, of course. So, did you understand? Gas. Yes, see, I'm giving you another example. See, this is molecule number 1. You can take only the cap. This is molecule number 1 and this is molecule number 2. Get it? See, number 1, number 2. Yes, it is even clearly mentioned. Yes, that there is much gap between these two. So this is the gas state of matter. Get it? Yes, hope you understood the solid, liquid and gas. Yes, these are the states of matter. So what we have discussed, can we revise? So we discussed about solids, liquids and gases. So what is matter? So the pen is also an example of matter. What is molecules? We discussed the states of matter, and solid is the first one. You can see that they are tightly packed. You can observe that these pens are tightly packed. They are that tightly packed that they cannot even fall even if I tilt. And next we discuss the liquid. So you can observe here they have little gap, they are loosely packed. You can observe these pens, they are loosely packed. And for example, this liquid, it is taking the shape of this container, which is the bottle. Yes, here it is zoomed out. Yes, it is zoomed out that it is taking that shape of the container. And here gases, they can move freely at the high speed. They can move. You can observe very clearly here, and you can take the example of these two pens, and you can imagine these are molecules, and you can see the gap between these two. Yes, this is what we discussed today. So hope you enjoyed this video. So thank you for watching. So hope you learned something today. So bye, this is me, Ruchira. Keep watching my channel. So hope you will enjoy. Bye bye, have a nice day.